Thank you. Okay, thank you. Right, the goal of the speaker in this slot is to, it was already mentioned before, but now I really have a challenge to keep you awake. I know all had a very wonderful lunch, and I'm glad you made it back. So this is outstanding, and I'm hopeful, right, that we'll be able to have some participation here. We'll have a few things happening to give you a little bit of lay of the land here. One is to certainly share a little bit about what the heck is this thing called COMAP anyways? I realize that people might not know what it is. And you know, the thing, I've been in this role I've been involved with COMAP for many years, but I left academia as being a faculty member at a university to join COMAP full-time as the executive director. And I swear to you that there are family members I had that said, why did you leave math to go and study geography? Okay, the joke is lost, I can see, but okay. So I'm just trying to warm things up. But we've got, right, so it's not about maps, even though math is about maps in some cases. But yeah, so it's the Consortium for Mathematics and its applications. And of course, right, we're all in it together. We know what modeling is. So the goal of this afternoon session really is to say, here's a little bit on the perspective of what's happening in the world of COMAP, how you can be part of it, because I'd say that IMMC is all about building modeling community. And that's what we care about at COMAP and care about at NeoUnion. And then and part of that is to continue that conversation by participation. And when I say that, it's like we'll get to hear from the perspective of a very successful teacher in modeling in Hong Kong, who will be up here. And then we'll bring up a panel of 3 of our teachers of our top teams that are here with us today. And we'll have them join us. And maybe, I'll say right now, there'll be opportunity for everyone to participate who's interested in doing that. We may not have even kept track of all the people who will be up here on the panel. So that'll be outstanding. And it is something where I encourage people to all say something here, right? So, you know, let's see how interactive we can be. I'm trying to I'll gauge my time with those folks over here. I know we had a little bit of a later start. I don't know what that comes out as overall. But, of course, I would not be here at all if it was not for folks like Saul Garfunkel that we saw before we started today. If it were not for Alfred Chung and NeoUnion, his team, if it weren't for the Education Bureau of Hong Kong, and it weren't for the university here, and other universities in Hong Kong that have been so supportive of this event, which is outstanding. So thank you to everyone who's offered that help and support of modeling. And we certainly want to maintain your interest. Let's see what we can talk about here. All right, so what do we got? What do we got? Well, this is one thing I realized I never even told people where COMAP is. I don't know if you know. I don't know if this even helps describe it. So I just have a little bit of the northeastern United States on the board there. You can see my little COMAP symbol. It's pointing up into this area that's a little bit outside of Boston. I'm also pointing this out because we hope to see people there next year for the IMMC Summit, as we will, you know, COMAP will be the host, and we're excited to have everyone join us. I'm also saying, you know, what does COMAP stand for? You can see these ideas that are up there. But also a little bit about me, because I think you always have to talk about yourself a little bit so people know your perspective. So I'm in Bedford, Massachusetts, the formal home of COMAP, quite frequently. But my actual home is basically in Canada. The tip of it doesn't touch Canada. It looks like it on there. It's just a bad icon, right? So, a bad picture. So, I am very close up there, and I've often described people, the reason I say that is similar, they're like, where are you from? I'm from New York. It's true. And they're like, oh, New York City. I'm like, no, not at all. It's the furthest thing from New York City you could be in. In fact, it's about 6 hours from New York City. We have many folks here from New York that are much, 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 much closer than I am. It's only 2 hours from Montreal. So that's usually how I get places. But key things with COMAP, you can see folks have been working on this for a long time. Folks in this room have been working on it for a long time. You know, members of the organizing committee, the expert panel, they are pioneers in this area, right, in doing this great work in modeling. And COMAP has, I think, been a great support in those folks for many years, right, in doing these things. And as Saul said, we've done a great job, but we've got to do more. So, you can see I have this right there. What is COMAP? I try to describe it in other ways because now that when people say COMAP, what do you mean? And I'm like, so here's my test with you. It's math for decision makers, right? Everyone's enthusiastic about that. They can see there's a slogan there. Okay, good. All right, what does COMAP do, right? Once again, just to tell you, what does it do? Well, clearly we're here, so I'm not talking, we're at the IMMC. This is outstanding and exciting. There's other contests we run. You might be aware of them. We'll talk a little bit more about those in a bit. We also publish some journals. We also have quite an extensive collection of materials that I'll bring back later, and we could talk about activities that we can all do together that could be really exciting for all of you, that all support, once again, COMAP is all about math modeling. So a number of these things are happening here. Like I said, this is supposed to be a very short thing, but to actually give you some context in recognizing or understanding what COMAP is, rather than just some letters. But now here's the part we get to talk about. This is probably more about me. So I don't know, I'm a little bit worried that I am a performer. You said you weren't. No, I don't know, but maybe I wish to be one, because I certainly like things like karaoke. I don't know if anyone else here does too. I'm not gonna do karaoke, don't worry. You might be worried right now, but it's not gonna happen yet. I'm not, and I'll say, I'm not good at it, I just like it, right? It's enthusiasm. But has anyone ever seen this type of thing before? That's my first question. Anyone? I see some hands raised. All right, the first hand I saw was right there. Where have you seen this? Yes. Random places in malls. Great. Now, which mall, which country? Where is it? In China. Excellent. Okay. Anyone else? Has anyone else seen this? Singapore. Yes. Anyone else seen this? Yes. Oh, you saw it. Oh, airport in Europe. Okay. Outstanding. Okay, so I saw this for the first time in Singapore. Angeles she knew. So I saw it there, but I love that I knew there had to be other ones, other places. And so first of all, I saw this, and I was thirsty, and I thought I'd try it. But I just keep this in mind, right? So I saw this right here, and I was just thinking about this, and I was like, that is wonderful. There's a few things you might notice there. Just to people, has anyone else who has seen it, have you actually used it before? Oh, I see some yeses. Okay, you've actually used it. Is it good? Do you think it's good? Well, already, from your perspective, well, there might be something different. Just keep that in mind. All right, so I'll turn the page, if you will. All right, here's a few more instances. Now you can see this is probably too much into my mind. I'm now taking pictures of these machines. These are all in Singapore. I'm potentially obsessed with them. But is there anything that you at all notice about these different machines at all? Or different things that are going on? Anything that you see there? I'm just wondering what people notice, and I realize the pictures might be small from your perspective. They're never low on oranges. Oh, that's a pretty good one. Okay, never low on oranges. Yes, okay. They have a direct connection to Australia. Somehow they just... there's no... I was wondering. I was going to ask Christy that. I forgot to ask her, but I didn't want to give anything away. Okay. Anything else that people notice thus far? Or people who have seen the machine before. Anything interesting about it? It's usually dirty? Oh, I thought mine was clean. Oh. Well, then that's an issue, right? Okay. Yes, I don't want to visit those ones. It must have been that Singapore ones were very good shape. They're in very good shape. All right, so one of the things that I had started to notice, and this is to point out how I was excited by this, but also I'm always very slow trigger on my phone. So the first thing that I had noticed was I wanted to just take a video of it making the juice because I was excited and probably thirsty or something. And it's hot in Singapore, so it's hot here. So I had that, and you can see over on the left-hand side on that first one, it's actually the little juice characters walking around telling me what % my juice is and being made, so I'm probably excited by that. And that's happening. But it's, of course, I didn't take a video, I took a still photo. Then I went to this middle one. I found this one in the Singapore Zoo. And I don't know if you can make it out, but there's something different. You'll see some differences between that one and this other one that was just located in the, more or less like the lobby of the right below our hotel. We were staying in Singapore. And I say our because there's other people in this room, expert panel, we were there. And they were both there, and there was some number of differences there. So let me focus this. You said you weren't noticing differences, but let's see what if I zoom in on some of the things that I notice as differences. It's not the only differences that are there, I promise you. So here's my zoom in. I hope this is readable. Okay. What do we got? What are some things that maybe you could tell that I noticed that maybe now you notice? Yeah, you saw it, what? Oh, yeah, you saw that machine. I know. Yeah, you were there, right? Yeah. Yeah, I know you've seen this machine. You've seen this machine. Okay, anyone else? Yeah, you saw some differences. What do we got? Yeah, there's, the buy 10, get 1 free, so that could be something interesting. I'll tell you what I was most excited by first is that they keep track of every single orange juice they sell, apparently. Right? Every single one is somehow on a network. Even the dirty ones in Switzerland are somehow part of the orange juice network. And they are keeping track of these all the time. So I found that interesting. And like I said, this is a little bit of like, where are we going with this? Okay, so there's some numbers there. Another thing that I noticed, and once again, I'm trying to tell you which ones these came from. Or is there something else different that you might notice here? Well, I found it interesting that when I went to the zoo, where I already paid a lot of money to go there, now I had to pay more money for my orange juice? Why do I have to pay 3 Singapore dollars versus 2 when I'm in the city? I don't know why. That seems to be strange to me. I wasn't very happy about that. And but it does keep track. It does a very good job of keeping track of some of the things, like you can see I have the timestamp right there. So I love how they're doing this, right? They're giving all this information. Do you have any questions now about it? I know, that also was very interesting to me. Why is it not the same temperature for all the machines? I know. See, now I need you to go back to Switzerland and do research for me, Matteo, on those machines. So what do we have then? If anything, are there other questions you might be considering? Now, I want to take you back to Dr. Nis's talk, right? Maybe we're thinking about modeling in some of those terms. Take you back to Alison Chang's talk, right? Think about these things like things you might wonder about or notice that are happening here. But I also want to say, this is like not a defined question here. What are things you might be wondering? I know there's things I'm wondering, and I had them before, and I'll even wonder more. Maybe one of the first ones is just, do we have any sense of, like, they've sold 147 million plus, probably, and actually, so how many have they sold now? What? Yeah. How much orange juice have they sold now? Could be one of them, right? Am I saying that that's the world's most interesting question? Maybe not necessarily, but maybe there's other questions that come out of it. How could I do some even basic things to start to figure these things? Like, is there other questions that might be coming up? Yes? Yeah, so right. So once again, we're not talking the level of math that we saw teams perform on the contest here. We're looking at this though with a perspective. If we're interested mathematically in things that are happening in the world, and we have this opportunity to say, like, all right, that's interesting. I'm noticing there's some sort of rate of sale that's happening here, right? So it's very accessible math, and potentially, let's maybe take a look at it. I don't know. So you all took a look at it. What did you can even do some rough math, and I'll do some rough math there. Like, once again, I'm not going to do all the work for you. So maybe the first thing, that wasn't supposed to be what's up there, but we'll keep that up there to say, like, this is another version. We've seen other modeling cycles. This one's more, I'd say when I typically, anyways, it's a different version of the modeling cycle. We have it in the game report. I can talk about that from the perspective of COMAP and SIAM. But, so we haven't really identified what the problem is, but maybe we're going to say like, so how much is actually sold? And maybe I start to think about this like as a business proposition, right? Is the fresh orange juice business a good one to get into? Or maybe there should be others, right? Is it one I should get into? Because this way, if I do some really rough math, if you looked at those timestamps, once again, the focus is not to have you do that. We had about 21 hours, and I just took the difference, divided by 21, we got an hourly rate. All right, that's a lot of orange juice. For me, I did a little like, back of the envelope math there too. Once again, I'm estimating things, making some assumptions. We might want to talk about those more. But I'm also figuring that like, wow, if they're selling it this quickly, at this rate, it's only like, this machine's only been up for less than 3 years. If I go back in time, I don't think that's the case maybe, right? You should argue with me, so that's interesting. Maybe there's a lot of problems in doing that. What else do you think we need, right? What would I do after that if I got that data? We just had, I said, Professor Niss was mentioning this, right? I should probably reflect somewhat. I have an answer to something that's just sort of ballparking ideas. And I'd really look at this and say is there other data we could get or other information? Well, I did get other data. Look, it's like a picture in a picture. That was an exciting one. It's me looking at the machine, then me taking a picture of myself looking at them. Isn't this exciting? I know, for me it is. And no one else is excited about the orange juice. But you can see right there, we've got a difference, and this was almost exactly 1 day later. But if you can see those numbers, and I can a little bit right there, that's a 208,306, it's significantly less. It's only 3,460 sold per hour using this data as compared to the other one. So clearly what that means is that I think it was Tuesdays are a big orange juice day, Wednesdays are not. Is that the answer? Right, that's the answer. Everyone drinks orange juice on Tuesdays. Only half that many people drink it on Wednesdays. No, I don't. But now I feel like I'm really intrigued because now I have this data and I really want to dig into this more. Can I collect more? Of course I can. Can I sit there and watch the orange juice machines all the time? No, I cannot, because I have a life, maybe, barely, and I'm interested in other things. And so maybe I want to investigate other types of questions, right, and use that as a starting point for doing these things. But having seen this and having something that provides this opportunity for me, it's really exciting. Do I want to create one with lemons? No one's gonna, I would say probably then I also need sugar or something. It's gonna be very complicated. It's not as clear-cut a machine. If I do it I know that in here I've had, in the US I don't really have watermelon water or something like that, watermelon drink. That seems like it'd be very problematic too, just like the weight in the machine. Probably not gonna work very well. Maybe it's we can go through this and see, so there's other ways. I'm doing some engineering here, thinking about these things. And overall, I do think, when I do this, and especially if I start to identify specific problems, I really do get to engage in the whole modeling process in different aspects of this, even though I'm still not with a real answer. And that's part of it, is to leave you there to say, what's something you want to explore that you might encounter in your lives? And that more really is the focus of what we're talking about here. So in the world of CoMap, and things that are happening. One of the things that I've had the opportunity to do by being in this role, just for, like I said, over a year, is unlike your teachers, unlike other folks here, I've had this break from teaching, which means now I'm doing this full time. I have the opportunity to think about modeling all the time, and really think about this idea of something to put things together, where I really, not that this is necessarily new, but it's a focal point for CoMap, and I think for how we share modeling with teachers, because we'll hear from teachers in just a few moments. We're almost at that point. But the type of thing that I think I'm emphasizing when I look at that is, what is your perspective on modeling? To my students that are out there, to my teachers, to everyone. When you see opportunities to use quantitative tools to investigate the real world, what do you do? What's your perspective? And so this idea of a modeling mindset is one that I'm confident is instilled already in many of us and has been spoken about by a number of us already, and something that really, I think, connects with a lot of these ideas here. To be more specific about it, and I can, of course, I'm not going to go into the details of just, these are a few of the things that are happening when you're doing modeling, but one of the aspects, one of the reasons that was part of the creation for this too, does tie back to teacher development in the United States. So, and I know it's I've talked to teachers in other countries as well, and it's these ideas of really needing to be intentional when we talk about modeling. I feel like there's been a lot of instances in which, and you might say orange juice, how is that being intentional? It's not about the orange juice, trust me. But when I'm talking about that, it means that I'll often have if I have an opportunity to have a workshop, and it's, I was saying like in some cases a half-day workshop is one of the ones where I can find space for that. I have an audience, it's a good size. We have a good time. People sometimes laugh at my jokes even, right? So I feel a little happy. And then what happens is, and we get to do, so typically we do some modeling, right, to get that experience. We get some practice from that behavior. We're modeling that facilitation process. And then we get to the end of the workshop and people are all revved up, they're ready to go, and they're like, oh, but I teach geometry. Exactly what do I do in that class to do modeling? I teach calculus. Exactly what do I do to teach that in that class, right? Whatever my class is, it's differential. Tell me the exact thing that's supposed to, well, differential equations should be very obvious, but we won't go there. But in some of these classes, it's like, what's exactly that thing that I can do? And that's where my own reflection, right, using this modeling practices to review what I do, I was like, we're maybe not doing the best job at always providing these tools. We're providing things on, and this actually was mentioned by our folks at Educational Bureau, right? Sometimes when we give everyone, you give them the world to look at, or modeling problems like you all have worked on in these contests, those are really big problems, right? The classroom setting, and you might think about your classmates in other classes, they might not be as prepared as you are to digest those, and even to break those down into pieces. How are they going to do that? So how can COMAP, so COMAP's focus right now is this idea of intentionality, and I'd add to that too. These the other things that I see here that we get out of modeling, and this is just to give more, because once again, I'm a math modeling cheerleader. These ideas are, what are the other things that we get? Well, this whole aspect, right, of course, we have all these tools that include things like collaboration and communication, and I'd even say you have to navigate and negotiate and do these other things with teammates, right? All these things that come out that I try to tell teachers about now, like, you need to do this. But once again, it's not answering the question of, what is it you're going to do? What is that thing, when I don't see you anymore, you're going to do? So, as we develop professional development, we have even more focus, like I said, on intentionality, but even more so because the sort of professional society that is largest in the United States is called the National Council of Teachers of Mathematics, or NCTM, and they've actually been promoting modeling as well. But, as probably is not so surprising, they've done it in a confusing way. Thank you. I know I get some laughs sometimes. And some of that is because now we have things like, oh my gosh, there's data science, there's obviously different programming. There's working with, they're gonna say it's statistics. What's the hot thing? I don't know what to do next. There's too many new things. Is math modeling part of that? And the answer is yes. That's part of the intentionality here, is this recognition that we had from all our speakers here. And that math modeling does bring those things together. That's part of the math modeling mindset too, to erase that confusion, to say that if you have this focus on math modeling, you are getting access to all these things that might seem confusing. And so it's trying to unmuddy the waters that are happening in the US. And so part of that then is to say, what's the structure? Once again, very lightly, I've been trying to work with things. We have this nice tree here, right? And as I describe it, we have many things. If I'm doing modeling, then I'm actually prepared to teach it. But I have to do that first. So if I'm really looking at the root system, this is this tree picture that I borrowed from online, and it's not perfect for my needs, but it's kind of nice. It's way too symmetric for actual modeling. So please excuse that. But yeah, so I'm doing modeling. That's at the focus. I get up here. I'm actually focused on facilitating modeling. It's an aspect that I do in my professional development. I want to get those pieces there. But now we move up to the tree. We have all these branches. We have all these leaves. We have all these other things to do. And that gives us this opportunity to actually have some different classroom specificity. That really is the thing that I keep hearing from the teachers that I work with. And I'll say that the teachers I work with are not the teachers that are entering teams in the contest right away, okay? The teachers here, and that's what I'm excited to hear from them when they're thinking about what their colleagues do, because we're already on team modeling. We just want everyone to be on team modeling, right? And I'm trying to get those people there. And I want to point out that, once again, that's why I did choose this tree, is because there's a little bit of intertwinedness, and we know that modeling should not just be in a branch by itself, and it's not just one method and one approach that's going to solve that. We just saw all of that today, right? And we're going to see more of it after this when we have more great teams come and share us things that what they've done. Multiple approaches for similar problems, and right, we know all models are wrong, but some models are useful, right? Sort of idea. We've got lots of ways of approaching things. They can all inform, but yeah, to go back to that, to say they're not all wrong, I think that was exactly, they're actually, we have no way of demonstrating, well, we have some ways of demonstrating that, but we can demonstrate that good models can be very different. So we've got these different approaches that are up there, and that is what we are working on, and very excited at COMAP and with partners like NeoUnion and others to share and support as we move forward. So examples of how this is happening now is that we have specific classes is one approach to this. And I don't know if I get a little bit closer, it gets a little bit louder, but I think I'm usually a loudspeaker. People can hear me. As we have something in many US universities, they will have these large, almost like lecture halls, larger size lecture halls of this size, where they'll teach an applied calculus course. And I'll be honest with you, this one in particular, it's like when I was a graduate student, it was a course called Calculus for the Biological Sciences. So in the US, that typically is designed for pre-med students, because they have to have a class that says calculus in it on their transcript. But they didn't take AP Calculus or something like that. And so it's like, take calculus, but not with the same rigor that we would ever find like in one of the classes I'm sure people here would take. Still, though, this is something where it's a great opportunity because it ends up being a terminal course, which means like it should not be the last math course at all, but it ends up being potentially the last math course that someone takes, and instead have a modeling first approach to that. And we have a team of these schools really led first by UCLA, and they're creating these materials, and we have basically, we get to utilize some artificial intelligence to take these different curriculums built by these 7 different schools. I was gonna say that one with the Bobcat is a place called Texas State. The one with the slug, that's a slug, that yellow thing. It's the University of California, Santa Cruz banana slugs. And they were the hosts for the first time we did this workshop with everyone there. And Santa Cruz it's beautiful. I just have to say that's a really pretty place to be. But you can see Arizona, Cornell has the bear, Harvard, Johns Hopkins. Those are the ones that are up there. So they're all coming together, and they've developed these materials, and now it's a way for other folks to really build this community of like, you teach this course anyways. We've got the materials for you. You don't have to use all one set of them. And we have got good tools, right? This is a way to use AI to sort of combine things together in places, almost build your own course structure, but also build a community around it. Similarly, at the high school level, we have NC State. They have a data science and AI academy, and they have a course they're focused on, and tied to that is specific professional development. So in that one, when they bring teachers together, they all are starting out with, what is modeling? Let's do it. and let's start to teach it, and then let's specifically focus on this course. So you can maybe picture that tree that I had back there just a moment ago. I think I can go back up there. Nope, maybe, yes. Oh, no, okay, yes, the tree. And think like in both cases, we have some opportunity to engage in some of those activities that are happening there. So the tree is still worthwhile for those things. And also, just a shout out from last time I was here, we're not forgetting about the fact that STEM, right? Or, was it Alfred? Yeah. STEM, right? It's the roots. Yeah. It's so important for STEAM, right? We see it right there. It's in the roots, right? So it's everything. We need it to support all of it. Yes. So it's a foundation. So what? Oh, I thought we had other things. So other things that Co-op does, and this is, I was going to say, the thing that's probably most obvious. You are here. We have our 2026 dates up there. I will point out this one, we don't have the other poster, so I'll put that on top of it, just make an ugly poster. But I do want to invite, to say, like, of course, contests are more than just fun. I think you have all proved it, right? They're more than just fun. They're also this way to really test yourself, see where you can be, and there are outcomes that are really valuable. So the other contests that COMAP runs on an annual basis, of course, IMMC. We have our partners here. We also have, I'll point out on your right-hand side, is both the high school and the middle school MCM contests. Those ones you have actually that full 2-week period to engage in the time to do those contests. Do not, this is the mistake, and actually I think we'll change this sometime soon. Do not try to spend the full 2 weeks just doing the contest. Just think how crazy that would make you. Do not do that, okay? I'm just telling you right now. Just choose choose your own window of time to do that. This is there's some historical baggage here that I have to clean up from things that happened a few years ago, all right? For why it has that full 2-week window. But we've got some good problems there, good challenges for you, and when you're all in your awesome schools as undergraduates and doing these things in university, you want to participate in the MCM ICM. And that one has no window, right? It's just 100 hours that starts on January 29th, which actually is January 30th in Hong Kong. Because it's January 29th in New York. Both in Potsdam, New York, where I live, and New York City. It's still the same time zone. Okay. Anyway, so we've got those contests, which you know about. And now, maybe the thing you didn't know. Oh my gosh. And I actually completely messed this up because I didn't want to tell you when these came from. It was supposed to be another quiz. I failed. But I wanted to show you materials from the COMAP archives. So COMAP has all these things because COMAP's been around since 1980. And what I want to really point out, though, and what I'm really leading a charge for, is in doing these specific activities that are intentional for different classes, we don't need to create all this new curriculum from scratch, right? We need to make it current. We should probably incorporate current technologies, right? Use things that actually have context that makes sense to us today, because I'm sure some of these are older than some people's parents here, right? These materials here. But these are some great activities that I was excited to put this up there because we had Professor Nis just show us. He's like, oh, how long are you going to be in the shopping line? That's exactly a problem that COMAP did, a long time ago. I'll just say it that way. We won't even go to the years, right? Many years ago, there was a COMAP module. Each one of these modules, it's like maybe 5 pages long. This module of a lifetime of automobile expense, it is a classic one that every pre-calculus or Algebra 2 class in the world has. All it's doing is saying, what's the time value of money, right? What's kind of cool about it is that, of course, they calculated time value of money out to 2046 in 1989. We're not there yet, and you know what? I think they're wrong. So we get to do exactly what we had right here. We get to review their model. We could start at that reflection phase. We could go and say, hey, what's not right with this? How can we make that better? In many cases, they were assuming inflation was constant, and they're wrong, right? Those types of things. But We could do more than that. Maybe we have a model that's better than just this basic model, right? We might be able to do that. We have this one right here, Life in the Fast Lane. Well, that one I get to point out to, and this is not to bother my colleagues and friends and teachers that I see in the US, because I know that you guys all do this, but this is a problem that's based on going to a shopping line, having some basic assumptions of, like, say, if I know how many people are there and I can gauge the, is their cart, full, half full, something like that. And then there's 2 versions of 10 lines of code. So they were running simulations and doing coding in 1992. This teacher, the teacher who wrote this and a few other teachers are doing it. And I still don't have that many classrooms that I know of in the US that are running simulations. And I'm like, this has been accessible to you for many, many, many years. We know now that problem. Why would that problem change now? What's different about checking out in a shopping market, potentially, or in a market that you go to? What? Self-checkout. Yes, self-checkout is going to be different. It still could be, that could be something that happens, right? We might have other things. Maybe you sometimes go into a store and you don't even have to pay at all. You just have you tap your card on in and you just take all your stuff and leave, or maybe it's even slower now. Who knows? But there is fun stuff that's up here, and this idea of something that's not typically in our curriculum, but this idea of I will if you will is really touching more on discrete mathematics and some idea of, of voting theory and these ideas of how, I experienced this especially in a two-party system in the United States, where there can be like 2 people who have all the power in a party of 100. So very interesting things that can happen and can be studied and should be, because they are relevant now. They might not be relevant in the same way. You might not be hopeful of having a DeLorean or whatever that car is over on the left-hand side there. I have no idea. Or actually, maybe, now it's a collector's item. So maybe you do want that car. I don't know. I can tell you one thing, none of those are e-cars, are electric vehicles. So, but I just thought that was a fun thing to do. And why would I say that? Because, why? Why do I talk about this? Because one of the things that we have at COMAP to invite all of you to be part of the community even more is do something called the Refresh for Relevance Challenge. I'm challenging you, because everyone in this room can do it. To go and take these old things, what about refreshing them? What if you like one of these? What if you go into COMAP's website and you access our materials, because you'll have access to really almost all of them, and then you're like, oh, I can make this current. So this one thing that I'm going to do, or the one thing that my colleague at my college or high school, right, is doing, I can make this something that fits what happens in their curriculum. So here's a very easy to find website that gives you access to these things, and you could go there and sign up and do that stuff. So that's one opportunity that I feel like is very community oriented, right? That connects with other things that we are doing. So you are all, like I said, invited to do that. And I'll say a little bit about this. Oh, I thought I had it there before, I don't, but there's also potentially prizes. Yeah, who likes prizes? No one likes prizes. Sad. But, oh, okay. All right, one person likes prizes. There's a prize. Okay. This is where I always wish I had like one of those t-shirt cannons. Have you ever seen those? That would be awesome. Or, yeah, okay. But, all right. So, so we've got something there that is really community oriented. And the main part of our community, though, are the people that are doing the teaching, right? The people that are out there. As I've mentioned, many people, I get the opportunity now to be here for COMAP, to see some of the things that are happening, to interact with people on different levels, sometimes even to get to go into classrooms and like run a lesson or two, but I know that I'm not there every day. So I have the honor right now of inviting Miss Beth Chen to come and join us and share her specific perspective from her school here in Hong Kong. As someone who teaches modeling. And then after we have her, we're going to invite up some panelists to have a further discussion on this. It will be a short, quick discussion, but it's a discussion that's supposed to prompt further discussion and ideas. So I'm going to turn it over to her, and you'll still have to hear from me since I'll moderate the other group. But this is all Ms. Beth Chen. Thank you.
Thank you, Professor Galso. Thank you for your introduction. I should have some self-introduction now. I'm from Diocesan Girls' School, a girls' school in Hong Kong. And today I'm honored to be here. Actually, I was invited by the EDB because they know that our school we have started the journey of mathematics modeling since the beginning, that is 2015. We participated in the first IMMC competition, and I myself joined the second IMMC competition back in 2016. And I still remember, I don't know if some of you remember that year, the problem was record insurance. That, I don't know, that was too old. Anyway, the reason I'm here is because we have more than 10 years of experience, and I'd love to share this authentic experience with you. So now my sharing will be based on the part that we are doing the teaching, and also the other part will be focused on the very short part focused on the competition. Now, first part is the course-based experience. I have to mention that this is much later than join the competition, but back in 2021, the EDB issued a circular to all schools in Hong Kong that we have extra hours shifted from one subject to all the other to other 3 core subjects. That basically in high school we get a few 20 hours extra, so we can dedicate this extra hours for basically whatever we think. Like the school has, from my understanding, the school has autonomy on using these extra hours. So at that time, we think, given the intensity of our curriculum, we are very entitled to dedicate the time to regular teaching. But after serious discussion, my school and my colleagues, we have decided to dedicate the time to mathematical ordering. We must, at that time we thought that because our experience in the competition, and we want to really extend this experience to all of our students. So we developed this course-based, basically 16-hour enrichment course for all our students. And that was not easy. I know that Professor Galuso just mentioned that from your website we have quite a lot of resources, and I had an account and I paid for all the resources myself. And it was a lot. I mean, that was a lot of material I could actually draw inspiration from. But not just me. In our school, we had a team, and I think about 10 math teachers we sat together and we discussed what should be the topic and how we can bring this experience to our students. So we considered and brainstormed for a whole summer, and we came up with this. I don't know it's suitable or not still today. We've been running it for a few years, but I still don't know if it's suitable, but I would like to share this course with all of you. It's based on graph theory. So we introduce the graph theory to all the students, and we give them mini tasks to do in the end. So I'll walk you through that. So at the beginning, it's not really difficult. We just introduce the idea, like you said, we just give them, oh, this is the concept, and this is nothing really different from a regular mathematics course. So we give them concepts, and then we give them exercise. This is very, very normal, right? And then, starting from the mini task, we had this planned out. So basically, we give them the first small task, that is to solve the 7 bridges problem. So that's their first taste. And then afterwards, we give them a problem that's more relevant to their own, to our own community. That if you serve as, we'll give the students this problem that if you serve as our athletics team captain, and can you plan out a running route for your team so that they can go through all the places around our school and they do not retrace the same route. So basically, this is what they did. It's a small task, but really they know how to, the idea we want to bring forward is that we want them to know that even a daily problem that has nothing to do with math, because it's PE basically, but we want them to think about, oh, I can use math to solve it. So that is our second mini task. And afterwards, we will introduce more math. The intensity of math is increasing now, so we give them all the very common algorithms, and we tell them what they can be applied to, and then basically they can have an idea, oh, this is some tool I can actually use now. So we have all these explained to them, and they have now they have sort of a bank, a knowledge bank at the back of their mind, so they can later on maybe use one of them. We actually we didn't expect them to use any of them, all of them. We just, as long as you can use some of them, and then it's okay. So we introduced all of it, not knowing this is real. We didn't know which one would work, but we introduced all of them. And then we give them a final task. The final task is to build a multi-day tour in Hong Kong, and they have to decide their own parameters. They have to decide their own decision formula to decide what is ultimately the best tour. They can consider the weather, the route, the time, the cost, anything they want. So it's very free, it's open-ended. And then I'm proud to show you one of the earliest products the student brought forward. This is a video. I will just show you just a clip of it. It's not the entire thing. I'll just show you what our students have done in the past.
Hello, we are Natalie, Samantha, Megan, and Abby of Class 4U. And in this video, we will be presenting on the ideas involved when working on this mini-task. But before we dive into the details, here is a short reflection of what we learned in this math modeling course. This math modeling course has been incredibly enriching and fun. Graph theory is certainly not something we are exposed to in the DSE curriculum, and we are really grateful that we have the opportunity to learn more about it. Through this course, we learned how to identify different circuits, such as the Eulerian circuit and the Hamiltonian circuit. Moreover, we learned how to find the shortest path using the nearest neighbor algorithm and the minimum spanning tree using Prim's algorithm. We got to apply the myriad of techniques in various small activities and in this final project, which greatly helps us solidify the different concepts we learned over the past weeks. The knowledge we gained can definitely be applied in our everyday lives. Now moving on to the details of the mini-task. First, we are told to select a number of tractions, and the tractions we chose are highlighted here on the screen. We also connected the different tractions here with blue lines. Next, we have to measure the distances between each pair
I
of
want to pause it here. Now, I just want to show you what they have done. And of course, this problem has no, in comparison to the IMMC problems, it's not really the same, but they have applied something and they're very proud. I just want to show you that. And also, I want to point out that this experience has been reviewed as very intricate, rewarding experience by my students. Because I don't know if you share the same experience with us, but as a girls' school, it's not so easy to promote math. I don't know. But it's kind of, they are more drawn to choir practice, dancing practice, and all that. But it's quite difficult for us to promote mathematics. And this activity actually brought them together as teams. As you can see that the girls work together, and some of them, maybe in the team that only one of them is really good at the algorithms, and the other one may be good at something else, maybe collecting information, maybe writing some codes, something like that. And working together, they can actually solve a math problem. And that is very, very precious, I think, in my teaching experience in our school. So that.
Attractions.
Sorry. Now I want to, the teaching is not over, but I want to talk about the competition experience as well. As I mentioned before, we've been joining IMMC from the beginning. We also joined the second competition is organized by ADB Hong Kong. And the last one is also mentioned by Professor. Yes. So we joined all these competitions. And you can see that our girls were presenting their ideas. And these were the most stressful time for them. I just want to show you that, how happy they were. But none of this can be compared to the next slides. As you can see, these pictures were taken right after we hand in the paper. So you can see how excited they were. I want to tell you this experience is that we have the time when we prepare for the competition. We also have the time during the competition and also have the time presenting our problems. But if I ask them, they're sitting right here, but ask them what is the most memorable part of the competition, that must be coming to join the presentation and listen to other teams presenting how they solve their problem. And that is, from my experiences, it's better than any teaching. And they get the chance to basically see, oh, what I have done. They're very interested in this way, because they will point out to the other team and say, oh, I have thought about that. We've done this part. We haven't done that part. It's very, very, I think that in that moment, they grew the most. So this is the competition part. Okay. Oh. So coming back to the course again, I also want to point out that a few hours, 16 hours during class is definitely not enough if we want to participate in the high quality competition like this. So we also, after joining the IMMC for a few years, I think 4 years ago, after listening to all the presentations and all the keywords from the presentations, and we decided to do after-school training. I know, some of you may say it's too much. But I had fun with the after-school training. And basically what I did is when I listen to the presentations, I just draw down the keywords and what kind of methods they use. A few years ago, it was AHP. So we study AHP and we teach our students AHP. And later on, we have our machine learning. We also have, today I heard the keyword clustering, K-clustering. That was very good. So we heard all these algorithms and all these methods, and then we search, and we not aiming to tell the students what exactly the principle behind each methods, each algorithms, but we aim to explain to them what these can do at least, so that interested students can then delve into it and then spend some time on their own. And then later on when they think, oh, if this problem can solve this, and then maybe I can research on them, it's a very fast way leading them to the competition level. So I want to show you some material that we developed in the past, dedicating to this course. After school, we also have math modeling challenge and training. And last year, we had all these topics, as you can see. These are very competition-based, and it's just what we have observed other people are using, so we teach them these, like the regression, fitting, and all these standard deviation, normal distribution, and all that. And these moving averages, because this is also the method used by a winning team in the past, and then we teach them that. And next year, we want to include more. And the course is also, it's very basic, so I'll just quickly show you that. So we give them, and then we tell them how to mold, and give them formulas, and then we teach them how to do it by hand. Where in reality, they don't even have to do it by hand. They can use for this, this is the least square method. I don't think they need to do it by hand, but they can use it. They understand it, and they can use it. And later on, we have AHP also taught to the students. And then we have a test in the end. This is also I want to share with you is that if you have a course and you don't have a test, and the girls will just forget about it. But in the end, we implemented a test so that, I have to do a test. And well, where do you find the questions? We find the questions from our examples, and also sometimes we include this kind of difficult question from some very famous universities. They're basically like their interview questions and all that. And these questions can be, I think, in my opinion, can be mathematically modeled. And we are not, I don't mark these papers based on their solutions. I just mark these papers based on how my girls present their ideas. So later on, we will have a panel discussion, and I look forward to sharing more with you. Thank you.
Okay, thank you. I think now if we could bring out some chairs, we'll invite some folks up here and back up here. And I might need also, just have to navigate the screens here a little bit. Let's see, pull it up. I think I should be right there. So, and I may have missed someone here. If someone else wants to join, I may have missed them. But I know that both Teeth Adhikari from Nepal, Carl Foree from Maclean's. I didn't college in New Zealand. I didn't completely butcher his name, I think. And Juliana Tsunami Almaguer Leal. I don't know your whole name. I don't think I can pronounce it all. I'm very bad. I'm sorry. What? Almaguer Leal from Prepatec in Mexico. There. Please come and join us. Please come and join us up here. I think we only need, yes, I'll sit on the side. I'll just be over here. And while they're getting ready up here, I know that it gives us a chance to continue this conversation. To certainly continue the conversation, I'll just be able to ask a few questions that they already had some opportunity to see here. Let's see if I can help myself in going to these as well. That'd probably be good. But also, I just want to point out that, my gosh, it's as if we had planned this thing. What a great example that we had from the school here in Hong Kong that's developing this math modeling mindset, right? Doing all these things we're talking about through a very directed type of problem, right? It fits in all these characteristics of if you're going to do graph theory. And that's why I want to highlight what it sounded like to me that, yes, why would you start with these very complicated open problems that we have but maybe some of you do that, but I feel like starting with those, that's overwhelming. And similar, the other thing that I've heard from teachers, that you didn't quite say it this way, but you were saying you got access to some materials, right? But it wasn't just some materials, it was a lot. So I got here on Saturday and got to experience tsunami a little bit. And right, this idea that the phrase, or this thing might talk about in the United States, or some sort of phrase here might be like, you can't drink from a fire hose sort of idea, right? There's just too much water. You don't actually get to drink anything because there's too much coming out. So the idea of there being dearth of materials is almost the same as being too much. And it's exactly that idea that I just want to say, it was really highlighting this idea of let's be specific and have intention in how we do these things. So it was really well shared by you. Thank you. Okay, so thank you for joining up here. Thank you to all these folks. I'd like to, as they answer a question, you're invited to introduce yourself more to the audience. But I think we've seen all these folks up here at some point today with their teams. And one of the first questions that I had presented to them was, what kinds of math modeling experiences do students typically have before they work with you and participating in the IMMC or other similar type contests? Now, we just saw this in Hong Kong, I think, right? We just saw some of your experiences that you share with students beforehand. Is there anyone of the other moderators up here who'd like to share what's something that your students typically do? How do they get involved? What's like the first thing they might do? Or how would you start to, yeah. Do you have anything? Yes, go for it, yeah.
Yes, in our campus, it depends, it varies depending on the experience. It depends on the program that they decide to study. Mm-hmm. For example, the students that were today participating, they are in the IB program. And this program applies more or try to use or incorporate more these type of challenges, so that they are able to expand the way they try to solve different type of problems.
Great. Okay. Is there anything similar to like a focus on a graph theory problem, right? That gives you experience in thinking maybe outside the typical math curriculum? Was there something that happened in either experiences, whether in Nepal or New Zealand, that your students would have done first before doing this? Before just giving them this question? Yeah.
We're at a government school in New Zealand. We're not a subject-specific school. We're not a topic-specific school. So basically, we take in any student who comes in our feeder area. We have to take them into our school. Yeah. What experience did our students have in modeling before this competition? Literally nothing. The examples that they saw of what they needed to do were the examples that were provided on the websites from the organizers as to the kind of standard and the type of standard that they needed to do. So specific maths modeling at the school, zero.
Yeah.
But I do think what has gone a long way is that there's a lot of stuff in the school that promotes mathematics in general. And that has been very positive for us. So there are compulsory competitions, national competitions organized by various universities, not just in mathematics, but there are also competitions in like informatics, in New Zealand engineering, math science competitions. And a lot of these competitions promote maths amongst our top students. But I think equally important is that many of my students here are also running a weekly program for their fellow students on just competition questions in general. And so you've got peers teaching peers and passing on not just knowledge, but I think more importantly, passion and a desire, and yeah, and I think that goes a long way from peers teaching peers in mathematics in general.
Yeah, that's a very good approach that it sounds like can happen in the other things too. Once they have the group dynamics, they're figuring that out. It sounds like in that instance. Now, if we don't have to have everyone answer all these things, but maybe I'll ask you, Atif, is there a way that that you work to help form teams?
Yes, so first of all, we are not a school. We are an institution, Mathematical Association of Nepal, and we do a selection test, but before that we give sort of training to the participants who decide to actually do modeling. And for that, we are really grateful. Like if you saw and if you noticed before, one of the Chinese person was also in our team, and he was the mentor in that boot camp as well. He is Xiaoxi from China, and we're really grateful to him for teaching the mathematical modeling concepts to our students. And this is how we have been training students just on the foundational level of mathematical modeling. And we hope to kind of get more, materials, resources, and then kind of better equip the students to prepare for mathematical modeling. So at this point, we just offer mentorship or bootcamp program, and then we do the selection test, and this is how they actually participate in IMMC.
Oh, okay. All right, so they're selection that way. Are there other ways, like when you're within the school setting, that you might, for any of you who have not mentioned something, you might determine you're going to have those, how would the group of 4 girls find each other, right? Or how does that happen? How do you find them? Do you say, you're going to be a team? How does that happen?
That's a very good question.
Okay.
And it's very difficult to answer. I have tried. I think I've tried so many ways to form a team. At the beginning, we want to, earlier years, we want this to basically one previous year, and these girls had experience, and we wanted the experience to be passed on to the next batch of students. So we try to form groups with different age groups, different ages. Like we have secondary 3, secondary 4, and secondary 5 in one team. So that although secondary 5 students graduate, and then we have the days move on, and then they will have younger students, sort of like an apprentice. Yeah. Because you also mentioned that the peers teaching each other. We also heavily rely on that. So at first we try to form these different age groups and then put them into one team. And later on we think, oh, that's too much. Because the S3 girls, they're too young, and the S5 girls, they have no time to really interact with them. And the time is so tight in IMMC, they only have 4 days or 5 days. So it doesn't work out. But how do we maintain this kind of succession and also bring them together so that they work together as a team? So later on we think that, oh, let's do this. We form teams of the same age, but we form multiple teams, but they will, later on they can share experience afterwards, after they have worked on this problem. So right now my answer is, yes, they form teams on their own. But in the past, we tried to force them and didn't work.
Okay, yes. And I know we've heard a little bit from others on that. That's very interesting, it is. But it sounds like a key aspect there, too, of maintaining a program, which is one of the things, is having that interconnectivity between the teams of different ages, right? And having that communication of like, what did you do? What did you try? Yeah. So that seems to tie in with some of the peer teaching that we hear it happens in peer-to-peer teaching that's happening in New Zealand or in Nepal as well. I thought I'd ask just to move things forward a little bit, but what are some of the changes, if any, that you saw, or I'd say, from your perspective as, this teacher and overseeing modeling happening, and some of you, I know it's been fewer years maybe doing this than others, but what are some of the benefits that you see in modeling? What would you tell someone else, a colleague at a different school? Why should they do this? What have you seen as changes in these? You can think of particular students, or maybe it's just your own experience and what you've seen in general. Are there things that you could share to someone else to say it's worth it? You should try this. And and part of that can be, it's worth to try this, even though I put an extra 16 hours on top of my teaching, or I stay after school and do these things, or I do these extra things. It's worth it. Because. Is there a reason for that?
Yeah, I think that the students that decide to participate on these type of challenges, and also when you incorporate these type of activities in your curricular class or your regular subject, it helps them visualize differently the way to approach to a problem. So they expand their perspective. So they became rigorous on how to start working on something, how to visualize it from different perspectives, and also be a bit more critical. So it helps them develop critical thinking so that you can end up with decision making, as you were telling before. Yeah.
Yes, please continue. If you have thoughts, please share with us.
So I would say students become independent. They become dependent on themselves. That's the most valuable skill they can learn from here, because they just don't only apply mathematics, but as Professor mentioned, they go into the non-mathematics stuffs as well. So researching about that things, they gain the skill to research some other things that will be important in the upcoming life chapters. That's what I want to add.
And maybe I'll ask then, do you have any examples of students that have graduated and are they engaged in modeling? We had, of course, some examples here. I don't know, I know we have some other graduates or alumni of IMMC in the room, certainly, right? We had a great speaker today who shared wonderful experience. I'm wondering also, I'm thinking, we had a parent of one of our competitors here who's a MCM alumni, and they use modeling in their lives. Are there any examples of this that you know of, students that have graduated? And even if they're not modeling directly, it somehow plays a role in them moving forward? Maybe you don't, offhand.
No, I don't. But what was coming out from both the MC and the speaker was that this is not something that happens overnight. So, for instance, our team was a team that this was I think the second IMMC competition that they entered, but as a team, they've been doing several competitions over years, and they have learnt how to complement each other and how to maximize each other's gifts so that it's not a one-person show. And I think that idea of working together over time is very important in terms of ultimate success. And so with their example, I do think that junior teams coming up need to see that it might happen when you start in your second last year at school, but it's probably not going to. You probably have more success if you start younger and learn the skills of the various competition requirements from a younger age.
And that seems to be consistent, right, with things that you said, with the keeping the teams within the same group, but having them coordinate and learn from each other things that work, and you bring back those skills. No, great things. And I do mention that because I do want to have, this is my, once again, call to action to all the wonderful modelers out there right now. You're all alumni of this program as well, right? You should contact me. I'll give you more information, right? You should let me know. Let Alfred and I know, because we want to be able to know what you're doing in 2 years, 4 years, 6 years, those sorts of things. Yes, and so let us know what happens with your modeling lives. And it doesn't have to, all those things. So that's great. What then, of course, please add to this, jump in. I already noticed, one of the answers saying, independence, right? That students come away with that. Students, there's a lot, though, also on knowing how to work in a team, in a group, that was just mentioned right here, that plays a big role in being prepared for this. I'm wondering then, too, as you've done this thing that takes, and I think I'm fair in saying takes extra time, right, that you've all said, what sort of supports have you needed as teachers and advisors of these teams? Or is it sort of like all on your shoulders? Does that make sense? You know, have you received any supports? Are there any aspects that have been like, okay, I wasn't going to do this, but then I did? Or I have other people, you know, I can see this type of support being out there for others that would be the way to move someone into thinking about support, you know, being an advisor for a team. Is there anything you can think of?
I think that, yes, well, in our case, we have the support, principally from Angeles. Angeles helps me to move these type of events and promote this type of learning.
Yes.
And I can share this with all of the math department teachers, and they help me finding students that are interested in this type of challenges. So that's one way. Also, that it is very organized, and with a well-structured helps me a lot to check easier and to feedback students easier, because the structure that they get, it's going to be important on how fast I can check and I can understand their idea. So that clarity, that organization helps a lot.
And that seems helpful. Are there other things? It sounds like some of it might be that your curriculum that now you share, right? Is that true, Beth? That now that you've developed for just saying, like, here's an example of a shorter project that leads you into modeling. Have you shared, you've shared that with other teachers? Is it someone else taught that besides you?
Oh, I must make this disclaimer that I didn't, it's not all by myself.
Okay, yes.
Yeah, we had a team, and all of us worked together to develop this course for the students, and a lot of teachers are teaching it right now, not just me.
Well, already, that's a great example of that support, right? And having other, so when, maybe I can follow up and say, did you, before you first did it, did you talk to some of those other teachers? Or do you talk with each other with some frequency?
You know, I consider myself very lucky because I joined my school 10 years ago, and they won the first IMMC Outstanding Award, the first year. So, thank you. Yes, so I joined it, and then immediately I was led by my students. And they were enthusiastic, and they were very interested in this more than I do. And I could not say no to them. So at the very beginning, so that was already the atmosphere from our school, and then we have always been very interested. And I think that's because our girls, that they want to solve real-life problems more than just cold math. And that's one of the charm of mathematical modeling, and I promote that since then.
Wonderful. Yes. Are there other thoughts? And it doesn't just have to be.
I want to add that because just now you were mentioning, are there any following, like what are the students doing afterwards, after the competition? I want to mention that so far we haven't heard that they're working on mathematical modeling, but this competition, it does promote math-related subjects when it comes to the choice of university programs. Because traditionally they were more focused on law or medicine or something like that. But recent years we've seen that our students who participated in the modeling competition, they tend to have more leniency on computer science, math, and all the other math-related subjects.
Well, and I'm glad you brought that up, because that was one of the things we heard yesterday from the dean at the University of Hong Kong, that he says now he considers us to be in this post-disciplinary world, right? Where what's governing things? Math modeling mindset is, right? This idea of being able to connect ideas, connect disciplines. You're not living in just one discipline. You're using this thought ideas to do exactly what was just mentioned here. So you may not consider the work of some of your alumni, for our teachers out there, or the work you, wonderful students, are going to be doing as exactly math modeling, because it's not, your title is not math modeler at company XYZ, right? That's not your title. Or math modeling doctor, math modeling doctor or something. But you're doing math modeling. And we need you to come back and tell us about all that math modeling that you're doing and the way you're making all these connections. So that's a wonderful point to bring up. And I'd like to see if there's any comments or thoughts that we have from the audience, because there could be other suggestions. And if there's not suggestions that you want to share right now, you're always welcome to do that in the future. In fact, I'll put up some contact information in just a moment. But before I do that, I want to give our panelists one last opportunity. If there's other things that you thought of you'd like to share. Any things? Yes, please, Carl.
I don't know how popular this is going to be, but when it comes to this type of competition, or competitions in general, my attitude is, please don't enter it for the fun of it. It's a competition, so you enter it to win. If you don't win, that's fine, but don't go into a competition with the mindset of, this is fun. That doesn't make any sense to me. So if you compete, by definition, you don't go for the silver medal, you go for the gold medal. But I also think it's important to say that, and I'm not saying this is true of my students sitting here, but a lot of the students that we do have in my school, your worth is measured by what you achieve. And I think it's really important for us to get through to our students that I'm really proud of what you have achieved. I'm really proud of what your work ethic and the example that you set. But more importantly, I'm really proud of you, with or without your achievement. And that idea of your worth does not lie in what you do or don't achieve. Your worth lies in, you are made in the image of the living God. And that is where your value, your dignity, your beauty, your humanity is. I think we really need, as mathematicians, who can be in a very cold clinical sphere sometimes, I think it's really important that we bring that level of humanity into our subject.
Well, thank you. Yes, I think that there's, and thank you so much for sharing that. I think on that note, I'd like to thank all four of these panelists for joining us, for sharing wonderful insights, and know that I consider that while this session has concluded, this conversation is just the beginning. So please be in contact. There'll be different ways to find us. You all found your way here. So I know you can find your way to people that are involved with IMMC, and potentially with these four that have already provided wonderful advice. And I'm not putting you on the spot, you should do more, you don't have to do more, but also I think that their words will live on, and things that we can think about and reflect on and allow us to go back and have other communications with in the future, right? To say, I'd like to have some advice on what I could do next, right? Or I have a colleague, I know what I do, but I have a colleague who needs some help and support in doing this, and that would be valuable to have the advice of these folks and others that are out here that I know have all done wonderful things. So let's thank this group very, very much. Thank you so much.